Assalamu alaikum, dear student. We have in this video applications of double integrals. Our first application is area. So to find the area A of the region R, the region is given in the XY plan. The rule is double integral dx dy. Second application is the volume. So the volume V beneath the surface fxy, this is the surface, and above the region, this is the region R. So the volume which is bounded between the surface f of x and above the region R is given by double integral f of xy dx dy. The third application is mass. So if the function fxy is the density of a distribution of a mass in the region A in the xy plan, then the total mass m is given by double integral f of xy dx dy. The fourth application is the center of gravity. So the center of gravity of a mass m, the mass is given by the following rule. We want to find the center, which is an ordered pair x bar and y bar. So the center of the mass m of the region R has the coordinate x bar and y bar. X bar is given by the rule 1 over the mass double integration x times the function f of xy dx dy, and y bar is the same rule, but we have to multiply with y here, and x in the x bar. The last application is the moment of inertia. So the moment of inertia Ix and Iy of the mass in R about the x and y axes respectively are given by the following. Ix equal double integral y square, when you have x, y square times f of xy, and Iy is given by double integral x square times f of xy, and you need to find the answer. Then the polar moment of inertia, that means I naught, is given by the following equation. We need to find the sum of this integral and this integral, or simply we can write it as integral x square plus y square f of xy is as a common factor. We have the following example. Let fxy equal 1 be the mass density in the region in the figure. So our region R is here. Find the total mass and the center of gravity and the moments of inertia Ix, Iy, I naught. We're going to start first with the total mass. So to find the total mass, as here, total mass m, the rule is mass equal double integration over a region R f of xy dx dy. So this is the rule of total mass. The value of f of xy, it is given 1. So we're going to substitute 1 here. This integration will be double integral over a region R dx dy. To evaluate this double integral, we are going to use polar coordinates. So we're going to assume the value of x is r cosine theta and every y is r sine theta, and r is the radius, theta is the angle. As shown here in the region, r is between 0 and 1, and theta, the angle, is from 0 to pi over 2. Substituting all these in the total mass, so the total mass will be double integration integration with respect to theta from 0 to pi over 2 as we find here, and the integration with respect to r from 0 to 1. Polar coordinate, we use it to change the variable from xy to r theta. So this dx dy, as we studied in the previous video, we will replace it by r dr d theta. We have to integrate first with respect to r. This is the inner integration. Then we will integrate with respect to theta. So integration of r dr will be r squared over 2, and we have to substitute the value of r from 0 to 1. Then integration with respect to theta. Substituting r1, and when it is 0, everything will be 0. So this will be half d theta from 0 to pi over 2. Integration of this is half theta, and substitute pi over 2. It will be pi over 4. This is the total mass. And next, we need to find the center of gravity. Center of gravity means this coordinate x bar and y bar. The rule of x bar is 1 over the mass double integral x f of x dx dx dy, and here we have y. We first find x bar. The rule is 1 over m. M is the total mass, and we find m here is equal pi over 4. So we're going to substitute here 1 over pi over 4 will be 4 over pi. And the double integral also, we will use the polar coordinate r and theta. Theta is from 0 to pi over 2 and r is from 0 to 1. We have to change every x to r cosine theta and every y to r sine theta, and we have this function is equal to 1, so we substitute 1. We will have x is r cosine theta, and this will be r dr d theta. And we're going to multiply r with r. We're getting r squared cosine theta dr d theta. We're going to integrate first with respect to r, and we're going to treat theta as a constant. So this will be 4 over pi integration from 0 to pi over 2 for theta. Integral of r squared dr will be r cubed divided by 3 from 0 to 1. Cosine theta, we treat it as a constant. Then answer will be 4 over pi. Substituting r 1 minus 0, so we're getting 1 over 3. Integration of cosine theta d theta. Theta is from 0 to pi over 2. Integral of cosine theta is sine theta. Use calculator. Final answer will be 4 over 3 pi. This is the value of x bar. We need also to find y bar, the same idea, but we replace x by y in the integration, and you will get the same answer, 4 over 3 pi. Both of x bar and y bar is called the center of gravity. And now we want to find the moment of inertia, Ix, Iy, I0. Rule for Ix is double integral y squared f of x, y. And for Iy, the rule is double integral x squared. When we find the answer of both of them, we add the both answer, we get I0. So the moment of inertia Ix is double integration y squared times f of x, which is 1, times dx dy. We're going to use polar coordinate. We will change the variable from xy to r theta. So we will have two integration. First integral is with respect to theta from 0 to pi over 2 and r from 0 to 1. Then y square, the y is r sine theta, so square will be r square sine square theta, and dx dy is equal r dr d theta. We're going to integrate first with respect to r, so we multiply r square with r, it will be r cubed sine square theta. We find this integration with respect to r. First treat theta as a constant and keeping same limit of integration. Integration of r cube is r4 divided by 4 from 0 to 1 sine square theta d theta, and this will give us 1 over 4 integral from 0 to pi over 2 sine square theta d theta, and the final answer is pi over 16. Using the same way, we're going to find IY, also pi over 16. Why both have the same answer? The reason is of the symmetry. And to find I naught, we have to add IX plus IY. That means pi over 16 plus pi over 16. Answer will be pi over 8. So this is the moment of inertia.